Let's try to understand what is a random variable. So before understanding the concept of random variable, we will revisit the concept of sample space of a random experiment. Sample space of a random experiment is defined as a collection of all possible outcomes of a given random experiment. For example, if you toss a coin 2 times, then what are the 4 possible outcomes of this experiment? Head, head, you get head in both the tosses, either head, tail, 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 or tail, head. These are the four possible outcomes. And if you put it in a set, then it will constitute a sample space of this random experiment. Similarly, we can define one more random experiment that is throwing 2 dice simultaneously. So what are the possible outcomes? There are 6 sides of a dice, right? So either we can get 1 1 in both on both the dices, or similarly we can get 1 2 1 3 1 4 1 5 1 6, or 2 1 2 2 2 3 2 4 2 5 2 6. So what are how many possible outcomes are there? 36. 6 into 6. These possible outcomes are also known as sample points. So number of sample points of this sample space is 36. Now, since we have understood the concept of sample space and sample points, we can now learn the concept of random variable. So random variable assigns a real value to each sample point. So for a given random experiment, you will have a sample space, and to each sample point of that sample space, a random variable will assign a real number to it. So if we represent the lambda, we represent the sample point by lambda, then x lambda will be your mapping this sample point, and it can take value x, for example. So this is how we define a random variable. So don't confuse it with a variable like in general +2 calculus we see that the variable is like this, and some other function will be a function of a variable. So don't confuse it with that variable. Random variable is a mapping from a sample space to real line in general. It can be in complex plane also, but we will focus on the real, so in the real axis only. So if lambda is one sample point of that sample space, we will map it to x lambda, and it can take value x. Let's try to understand it more clearly with this picture. So if this is a sample space, right? So for example of our first example, we took head, head, tail, tail, and tail, head. So there are 4 possible outcomes or 4 possible sample points in this sample space. So if we define a random variable like this, that we are interested in finding the number of heads in that experiment, number of heads in that experiment. So if head, head comes, then we would say the number of heads are 2. If the tail, tail, we get tail, tail, then number of heads are 0. If we get tail, head, then the number of heads is 1. And similarly, if we get head, tail, the number of head is 1. So let's see if we define our random variable like this for this random experiment, then how will we map it, right? So head, head will map to 2, tail, tail will map to 0, and head, tail, and tail, head would map to 1, and this is a real line. This S, or the sample space, is also known as domain of this random variable x, and the values to which these sample points are mapped are also known as range of the random variable x. So for this particular case, what is the range? Range is 0, 1, 2. And what is the domain of this random variable? Head, head, tail, head, tail, tail, or head. So this is what we have studied, that we toss a coin twice, we get this, all possible outcomes of this experiment are put together in the sample space. These are also called the sample points, and we define a random variable, a mapping, in such a way that it gives you number of heads of this experiment. We perform the experiment of tossing a coin twice, and we see the number of heads. So this is what we have just studied. But we can also see that there is a probability associated with each random variable, not random variable, each value of the random variable. So what do I mean by this? That this random variable x, if we see the range of this is 0, 1, 2. So what is the probability that this random variable will take the value 0? So what is the probability that this random variable x would take the value 2? What is the probability that this random variable x will take the value 1? And what is the probability that this random variable x will take the value of 0? Why we are talking in terms of probabilities? Because we cannot certainly say that if when we toss a coin, that whether we will get the head or tail. We will talk in terms of probability, that this is the probability, or this is the you guess, right? So this is the guess with this probability we are going to get the number of heads or some output. So in order to evaluate the associated probability with each value of the random variable, we first assume that our coin is fair. Assume that coin is fair. What do I mean when I say the coin is fair? It means that there is no biasing towards heads or tails. So probability of heads will be half and probability of tails will be half. So in order to evaluate what are the probability of x is equal to 2, what are the possible events? What should be the possible event? It means when you toss the coin, you should get head, right? In the first time you should get head, and at the second toss also you should get head. So tossing the coin first times, if I represent it by event 1, and tossing the coin second time if I represent it by event 2. So this probability that you get head can be also written as probability that E1 is equal to H and E2 is equal to H. Means first event gives you heads and the second event give you head. Why I am multiplying it here? Because these two events are independent, right? Because the tossing of coin second time does not change what was the value when we tossed it first time, right? Toss the coin first time. So since we have already assumed that probability of heads and tails is half, so we will write it half and half. So the probability that the random variable will take the value 2 is 1 by 4. Similarly, we can evaluate what is the probability that random variable takes the value 1. Probability that random variable x will take the value 1 is nothing but probability that either head tail occurs, probability that tail head occurs, right? This you know from your probability course also. So this term you can further break it like this, right? That event 1 you get heads, in event 2 you get tails. Similarly, you can break it like this, and by putting that probability of heads is half and tails is 1, you just calculate it and you get it half. So the probability that random variable x will take the value of 1 equal to half. Similarly, you can evaluate what is the probability that the random variable x will take the value 0. It will happen when you get tail, right? At the first time also you get tail, and the second time also you get tail, and we are multiplying because these two events are independent, and we put the values, we will get the value of 1 by 4. So this is 1 by 4. And very interesting thing which you will notice, if you sum all these probabilities is equal to 1. It is quite obvious also, because x can take only these 3 values, because it is covering all the possible outcomes. So it cannot take any value other than these 3. So all the probabilities should sum up to 1, right? We can also plot the PMF of a random variable, of a discrete, because in particular it is actually a discrete random variable, because the values which this random variable can take are discrete, right? 0, 1, 2. So what is the, this is a random variable, and what is the PMF of this random variable? And this x is nothing but the values which this random variable can take. So what is the probability? This is representing at what is the probability that x is equal to 0, what is the probability that x is equal to 1, and what is the probability that x is equal to 2. So we represent the PMF by this notation, that what is the PMF of this random variable when it takes the value x. So Pxx is what is the probability that x is equal to x for the case of discrete random variable. So you can plot the PMF or probability mass function, the probability mass function of a discrete random variable like this. Our random variable can take the continuous values also. In that case, we call it a continuous random variable, and we define some other function for this, that is called probability density function. We'll discuss in the next session.